Welcome to Gerald Johan van Wa's educational channel. Today again I will add a new idea and I will go further from the last video that I made, and I will continue with my reasoning, and I will add another idea that is related with the book Sound in Form, which is a method with which to understand words, or words with a capital. This is the book. It's out on Trafford and you can check it out there. Now, I already talked about the idea of flat Earth. There is a certain region in which you can remain and associate a lot of things that are immediately into your own environment. You can use actually everything within a 2D projection and think that this is the reality. It is of course only a part of reality. You can use it for a few very simple practical ideas that doesn't go further than, let's say, 1 kilometer around you. Everything else, okay, you have to, this is about all the things that are in change, in a changeable perspective, so things that change, that need time, that are that have these kinds of frames. Okay, you have to try to estimate. I already explained that one of the associations that you can make is like, now everything is different. Everything is not straight anymore. It goes, we need something else, we need some other ideas. It is an estimation actually between 0 and infinity, and this equation that you see there is actually the equation that you use in mathematics to find out how things hang together. There's no other way how to get to know how things hang together. Within the two-dimensional world, you only will see the projection. You will not understand anything at all. You need the projection outwards to, let's say, the higher dimensions, but it's actually also a kind of estimation, a way of thinking that everything which is out of balance, you can see how it is connected. Within the two-dimensional frame, every projection that you make is not perfect. So even the scales of the maps that we have, of course, they are not perfect, because you see, if you make a projection of a sphere, it will be more or less an estimation in the middle. And yeah, if you really put it onto two squares and you put everything which is on the sphere onto a flat position, it will not work, because there are deviations. It doesn't match with all the scales, because you can see on the top of the sphere there's less space, and in the middle there's more space. So how can you fit that into a square which has space everywhere in the same amount, which is very difficult to make a very good map. So they made a lot of maps how to project the world and have more or less an idea, okay, how does it hang together, and if you really want to make the scales fit to what a sphere is, it will be very difficult. You will make mistakes if you don't deal with the idea that this is a projection only. There are some other examples which they use, but it's not very practical to use. They don't look very nice. But if you really want to know, like, how is the shortest distance on the sphere and how it works on a sphere, you always have to make the calculation again. So so that you make the projection in the other way around, and that you can see, for instance, what is the shortest cut between 2 points. Then you have to think in the sphere again, like a sphere. And there are a few websites I've found which is debunking the flat Earth theory, and they show also, like, if you don't deal with the disformations, you think that you can make a straight line from one point to another, and it doesn't fit. So you really have to make different calculations to know which is the shortest cut between spaces, which are, for instance, some spaces on the sphere, there's less space, and on the equation, of course, there's more space, there's more room, there's more. Then you have to calculate it different. So it is not very easy. So already on the scale of a two-dimensional frame, you will find difficulties there with the three-dimensional reality, which is actually even on our projections. So very important is, of course, so why is there a sphere? It's because this is much more practical for nature than a flat plane. The two-dimensional plane can only be a projection that you make it as simple as possible, and a lot of things you can explain on a two-dimensional plane on a paper, but if you really want to understand it, you will see immediately on the paper that it doesn't fit within the normal order of numbers. There are some scales are bigger than slower, and it's because there's an interconnection. The interconnections can only be felt because there is a gravity between round objects, and they circle around each other, and there's a gravity between it, and it makes connection. And this interconnection of worlds everywhere, also on a very small scale, on a large scale, is very practical, because then you can feel like how things are moving to each other, which are depending to each other. And then even on a projected scale, even if you use a two-dimensional scale, you will find out how things are interconnected. Sometimes it doesn't matter. So like if you're walking on the Earth, you can see there the Earth, and the gravity is the same everywhere, on the same height. It's the same everywhere. So if you walk on the Earth, then it's everywhere it's the same. So in fact, you can also neglect it. So even if you say like, okay, there's no gravity that has much influence on me, it is true that it's not having more influence on this point or another point. The interconnections, how it is related, it always remains the same. So if you have an idea that you think that the sphere of the Earth is important for some reasoning, it is not, because it's stable, it's always the same everywhere. So it's not always important to calculate it. So a lot of things can work on a two-dimensional scale if there's a stability and it doesn't change. So the interconnection between what you need in what you from which you make a connection with, sometimes can work on a two-dimensional scale, but very often you can see that there is an influence from somewhere else. So in that way, once you feel like there's an influence from somewhere else, that it's not really adding up, you're immediately connected with this gravity. This gravity connects with other objects, with other ideas, and it's the gravity which pulls you to the other ideas, towards the other things that you need. It's a psychological reference, which I already explained, and so there are two ways to intercept the idea how it is interconnected. So it's going towards the gravity of things, of your thinking, of how the reactions are, and so on, and try to estimate it. Here you see the flat Earth in the middle, and on the right you can see like this is going towards the horizon. So you try to estimate on the 0 point, on the infinity point, where is the gravity going. If you are pulled by gravity, by what you do, by the goals that you have, the real goals that you have, and you're honest with it, you will find, thanks to this gravity, in a psychological way, where you have to, where you can find the interconnections, because the gravity pulls you to everywhere where it is truly connected. So this is the prediction again. So within the two-dimensional frame, you don't have almost anything. It's just anything that is not connected, so you will not understand anything, you will not interconnect, you will not find intuition. The intuition, the reasoning, is always pointing towards the zero and the infinity, and there's the estimation. How can you estimate? Mathematics is very simple. It uses, with this equation, how can you estimate what is really going on in nature? You use this equation and you figure it out by mathematical means, what is connected with what. And you find out the laws of nature only by this. On the two-dimensional plane you will not find anything except like that you can you can eat, you can drink, and you can go to sleep. The two-dimensional plane is already explained by the law of gravity, how Einstein explained it with the gravity waves. It's a bit I mean, the more gravity there is, the more the space is no longer steady, like a two-dimensional plane. It already creates a three-dimensional plane, so even light doesn't go straight. It's attracted to this gravity, and that's why also there are demonstrations on the internet. You can see that how it easily goes into circles. Instead, it's simply and things that move to each other go easily into circles instead of going straight to each other. It is this idea that makes it so. But I'm not going to talk much about the three-dimensional aspects of how it affects our two-dimensional world. I will go a little bit further. I already explained in the last video, like the sun and the earth and the moon. Okay, they're also going around each other, and the gravity there is also a deviation, so that it doesn't want to go in a straight line. So it will try to move to the right or to the left, depending on where it is. It's not a very good example here. It's not exactly how the movements are, but this pulse towards the edges is a side effect that is dealt with, which I just gave as an example of that you can understand that the Earth is not really a circle into a circle. The movement is a little bit different. But I was going to talk about the moon. I didn't explain it fully. I only started an idea, and I'm going to finish this idea now. I said, like, gravity is not only related simply by the masses who are pulled to each other, like you can see in every object that the masses are pulled to each other. The closer they are to each other, the more gravity and the more force it has. But it's also connected with time frames, and that's what I was going to do. The moon is very much an example that the gravity is only strong at a certain time frame, which is strange, and you cannot explain it immediately. Why is the gravity pull at the full moon so strong, and the other points where the gravity is still there, you don't feel them? And I'm going to explain that now. So I will finish my idea that it's going to be a bit more clear. So you know, of course, from the moon how we see it. We see different phases from the moon. It's a rather regular system that where the moon is circling around the Earth, and the shadows also change slowly after 8, 15, 22, and then 28, or a bit more days. You will see different shadows. So it is kind of wave movement that is happening there. Here I express it a little bit different. The sun in the middle, the Earth the right and the left, and the summer and the winter, and the pull away. Also with the moon, it's a different circling around the Earth. On the left you will see the shadows. Also the shadows of the moon and the sun are actually always the same. Depending on where you are on Earth, how you can watch the moon passing by, but so it's not always at the same place, of course, but once at certain points in the year, of course, it's always the shadow is always on the same or on the day even. The shadows are always on the same side and exactly the same as the Earth is on the same side. But depending on where we are on Earth, if you're also in the night or in the sun at the day side, we see it from a different angle. So we see the angle from the Earth here, so you can see the moon from different positions. When the moon is at a different point in space, it will look different, of course. But here I will explain also the gravity. The gravity pull, why it is so strong during the full moon, is because there are two pulls here. The Earth is pulling towards the sun, the moon is pulling towards the Earth, and if you see it, of course, the sunlight is at the same point where the gravity is doubled. It's also exactly the same point where it is the full moon, and there's a small gravity on top there, because when the moon is further away from the Earth, and there's a stronger pull when the moon is closer to the Earth. But when there's the pull from the sun and the pull from the moon separate, okay, this is not a very strong pull, but it also has an influence on the tides and so on. And so there are four different strengths in which the moon itself pulls towards the Earth, and how it affects the tides and how it affects us. But the rhythms, how we are connected to the sun and to the moon, are interconnected in that way. When the full moon is there, the gravity is also the strongest, and so it has an effect on every rhythm in nature at that point. So here I explain it differently. So the small pulls are actually like as if they are dissolved into the strong pulls. So the small pulls, you hardly notice them, or you don't notice them. The earth, the water on the Earth, okay, bubbles a little bit like in the tides, but we don't really feel it. The strong pull, of course, just as with the tides, they are stronger. They are much stronger, and it is also pulls us towards all different systems. It's very simple explained. I might not have dealt with all the aspects, but you know the idea. So here you can see all the rhythms, and at some point, okay, some rhythm will be stronger, and the pulse will be stronger. It all comes down to that. We have the pull of the sun, and we have the pull of the moon, and the Earth in the middle, and so there is the full moon as well. So this is the only point that really matters, where you can see like, oh, here is the strongest pull, so we can define the moon also there. So the moon is not just defined by the phases, but the full moon, it is also the highlight of the whole phenomena that are related with the moon. Now, why do I explain it here? Because sound in form is about words. Now, let's just check how we express the word of the moon, and if this idea that is actually related, like how we describe the influence of the moon, not just how the moon looks like, but especially how the moon influences, that should be noticeable in the word. And I will try to find it out in my theory. In this case, is it related? Can you find that in the word? Yes or no? Let's find out. Let's use actually the letter M as we know it, and also as we know it in the Egyptian hieroglyph. The M here, actually it is, what can it mean? The M, it can be a mass, it's also structure, It's a structure which is a whole mass of events and really the full capacity of what we have. So it's the full, the whole mass of events, the full structure, everything is there in the M. If we add in the whole system, the whole structure, a couple of processes or regions, it is the O. The O are the regions in which the events take place. So the word moon, when it ends with the N, it means with the N, okay, you come to a certain point that you can take out. This is the idea that really expresses everything. So the N is there expressed on top. It's the element that comes out. So within the structure of the moon, the O is actually also always expressed with in 5 phases, so that fits it very well. So the moon is, as you can see here in the frame of what is the moon, there are phases in which one position especially comes out forward. It fits completely. If I now try to use another method, every letter also has as a value, as a numerical value, and these values, they also fit with dimensions. So I expressed in my book the dimensions in a very simple way, because in a way we only use 3 dimensions and then time as an expression where the changes occur and how much they occur. So it's also a 3-dimensional frame of time in which the changes appear. And this I express very simple, and I will express it very simple here in this video as well. So M is again the full structure of mass, and it has 3 dimensions, so it is a 3-dimensional structure in which there is a whole mass that we are going to analyze. What are we going to analyze there? It's not just one process, we have 2 processes in 5 dimensions. So 5 dimensions is always connected with a process with interactive time frames. So the interaction between the time phases also mostly means that there are changes throughout time, and so that one process is interconnected with different phases. That's the 5-dimensional frame in a very simple expression. So 2 processes in a 5-dimensional frame within a 3-dimensional world or frame. What comes out, so with the N, you have a distinction where you have resulting elements that come out, a certain content that comes out, and this last letter has 4 dimensions, meaning it's always within a certain moment that you achieve this. So there's a time frame where you achieve this after a while. So if you translate this to what the word moon means in just in the dimensions and in the content of what happens in these dimensions, it means there are some elements or an element that comes forward on a time frame because of the combined process of the attraction between 2 masses. So actually it is indeed a process between between the forces of gravity, in which there's a process that you can also see in a time frame in which changes occur. This is a process of our perception, and this is our estimation. Again, this is words are on the plane, not on a 2-dimensional plane, but in the estimation region in between. So we estimate what do we see there in what we can't see immediately in our 2-dimensional frame. What do we see there, and what does it mean? It expresses MOON. It expresses, we can feel that there's in the 3-dimensional plane there's an interaction of processes in which in certain time frames we notice a difference. In fact, that's more or less what it means. So here you have the expression again. I can make other expressions which express the same thing again, but so here again we tried in the gravity of what we notice. What is different here? We see at the horizon. What connection is there? What interconnection is there in the gravity pull towards the word that we try to understand? That's the expression of the word moon. It is that's all. Nothing more than that. Okay, thanks for watching again. I forgot to add the oops, and here it is. Okay, thank you for watching. That was the last frame. Visit my website if you like. There's a website which is made by the book company, GerardJohanVanWast.org, so it's already there. And the explanations you will not find in this book, but it is related with this book, Sound Inform. I try to make some videos every week. I would like to make one video at least from the series Educational Channel, and I will also always give examples that are not in the book. I think that's more fun, and you will learn something about the ideas, how it works, how you can think with the theory, and maybe you can learn it a little bit more easy. But if you really like to have the basis and thoroughly learn everything which leads to the understanding of vowels and consonants and how they hang together, just check the book out. Thanks for watching. See you next time. Bye.